Before opening the floor for questions, I'd like now to move to a presentation from CNSC staff as outlined in CMD 14H4 and H4.A. Mr. Elder, I understand you're going to make the presentation. Please go ahead.
Merci. Bonjour, Monsieur le Président et membres de la Commission. Mon nom est Peter Elder, Directeur général de la Direction de la réglementation de cycles et d'installations nucléaires. Avec moi, à ma gauche, est Pierre Tanguay, agent de projet pour le réacteur de McMaster et directeur par intérim de la division des laboratoires nucléaires et des réacteurs de recherche, qui fera la présentation aujourd'hui. As well, we have our team of specialists who have been involved in this review of McMaster's application for license renewal, who are ready to answer any questions the Commission may have. We will present today CNSC staff's assessment of the application by McMaster University to renew their operating license for a period of 10 years. I will now let Mr. Tanguay provide background information on McMaster's reactor design from a safety perspective and an overview of the performance of the facility over the last license period, as well as CNSC staff's recommendation for the renewal of McMaster's operating license.
Thank you, Mr. Elder. Good morning, Mr. Chair, members of the Commission. For the record, my name is Pierre Tanguay. I'm the Senior Project Officer and Acting Director for the Nuclear Laboratories and Research Reactors Division, and I'm responsible for the licensing and the compliance of the McMaster nuclear reactor. The McMaster nuclear reactor, or MNR, is a pool-type research reactor located on the campus of McMaster University in Hamilton, Ontario. MNR is a light water-cooled research reactor, and it can operate to a maximum of 5 megawatts thermal. MNR has been operated since 1959 when it achieved criticality for the first time. The reactor is enclosed within a thick reinforced concrete containment building, which protects the reactor from the environment and also prevents any release of contamination to the environment should an incident occur within the reactor building. MNR is used for teaching in the area of nuclear science and also for research in fundamental physics and materials science. It uses 6 beam ports, sample irradiation devices, and 1 hot cell. On this picture, we can see the core of the reactor at the bottom of the pool. It is the only reactor in Canada where a live core can be observed in operation completely safely. There are 2 sections in the pool, which can be isolated from each other, and the reactor core can be moved to either section if needed, adding to the safety features of MNR. McMaster uses neutron activation techniques for geological science, such as mineral characterization, environmental science, and archaeometry. Neutron radiographers perform radiography on a daily basis, notably on aircraft turbine blades, for the detection of flaws. McMaster is an important world producer of iodine-125 used in cancer treatment and other medical applications. The current license was issued in July 2007 and will expire on June 30th, 2014. In September 2013, McMaster University made an application for the renewal of their operating license for a period of 10 years. The application followed a standard format discussing all safety and control areas, as well as other matters relevant to this license application. CNSC staff have reviewed McMaster's application along with all background documents. CNSC staff are satisfied that the application is complete. The application shows that McMaster University continues to maintain a comprehensive set of programs in relation to all 14 safety and control areas and is making provisions for the protection of health, safety, security, and the environment, as well as the international obligations that Canada adheres to. In the next few slides, I will provide an update on the areas that were identified at the 2007 license application hearing, as requiring improvement in the context of evolving standards and regulatory framework. Areas for improvement were identified with the quality management program with a systematic approach to training, nuclear criticality safety, radiation protection, and fire protection. Improvements were undertaken by the licensee in all areas listed above, and CNSC staff performed compliance inspections to monitor progress. On the next few slides, we will look at the details of these improvements. The first area is on quality management, for which the implementation was assessed as below expectations in 2007. Over the license period, McMaster University updated their management system documentation and many of their processes and procedures. They also created a key position in quality management and training. Important top-level documents were updated with their policy manual and the organizational structure documents, which now reflect more accurately the roles and responsibilities of personnel within the organization. CNSC staff conducted 3 on-site inspections on the management system to verify the progress and compliance. Several desktop verifications were performed as McMaster University updated their documents. In 2013, an inspection was performed to verify that all actions were completed. With their revised program, documentation, and updated roles and responsibilities, McMaster has a management system that complies with CNSC expectations. The next area identified as requiring improvement at the 2007 license hearing is training. CNSC staff had recommended that McMaster implement a systematic approach to training, or SAT, for their certified positions. At the 2011 midterm performance report, CNSC staff reported that McMaster was making progress with the development of a SAT-based training program for reactor operators and reactor supervisors. CNSC staff conducted an inspection in 2013, and with further updates to their training documentation, McMaster completed all actions as required, and CNSC staff accepted their training program. McMaster's training and personnel certification programs are now assessed as satisfactory. The next area needing improvement in 2007 was on nuclear criticality safety. CNSC staff had requested that McMaster develop a nuclear criticality safety program that complies with the evolving standards and regulatory framework. McMaster revised their program documentation in 2009. After a review of the new program documents, CNSC staff accepted the revised program. CNSC staff conclude that McMaster has a nuclear criticality safety program that meets expectations. The radiation protection program documentation was also identified in 2007 as requiring some improvements. 5 compliance inspections were carried out at McMaster over the license period with a focus on radiation protection. McMaster followed through with program improvements and updates to their RP documentation. These improvements included training requirements for MNR staff and additional program requirements for investigation of unusual radiological results and an annual review of the suitability of the action levels. Further to the 2010 alpha contamination incident at Bruce, CNSC requested McMaster to perform a detailed assessment of the potential for alpha contamination hazards. The assessment confirmed that alpha-emitting radionuclides do not constitute a significant component of the radiological hazard. However, McMaster made some enhancements to include additional training, as well as monitoring and training of alpha-emitting radionuclides within the facility. These improvements were completed, and the revised radiation protection program manual was submitted and accepted by CNSC staff as part of this application for a license renewal. I will now discuss McMaster's performance in the area of radiation protection. There were 2 events which resulted in 3 action level exceedances over the license period. In 2007, there was an incident where an iodine technician was contaminated, which resulted in an effective dose of 0.2 millisievert. Then in 2011, an iodine technician received a minor wound to a hand with a contaminated object, which resulted in an effective dose of 0.4 millisievert and an extremity dose of 190 millisievert. This was presented to the Commission in an early notification report in September 2011. No regulatory dose limits were exceeded, and there was no health impact to the worker. McMaster undertook corrective actions, which CNSC staff verified for effectiveness. I will now present some data related to radiation protection. These numbers show that doses to workers and to the public are very low, well below regulatory limits. This graph shows the maximum effective dose to different categories of workers at McMaster over the license period, with the highest annual effective dose of 8.2 millisievert, which was received by a neutron radiographer in 2011. All the doses were well below regulatory limit, shown as a red line. The following graph shows the maximum extremity doses to different categories of workers at McMaster. The highest annual extremity dose is 190 millisievert and was received by an iodine production worker in 2011 as a result of a personnel contamination event, as I explained in an earlier slide. McMaster followed up with an action plan to reduce the likelihood of another similar incident. CNSC staff inspected the implementation of the actions, and we were satisfied with McMaster's response to this incident. The average worker extremity doses are low, well below the regulatory limit of 500 millisievert. This graph shows the estimated dose to the public from the operation of MNR. The estimated dose to the public is the maximum possible dose to a member of the public who would be standing at the location of the highest release for an entire year. The numbers range from 0.53 to 0.97 microsieverts, which is 1,000 times less than the regulatory dose limit of 1 millisievert per year for a member of the public. In concluding on McMaster's radiation protection program, CNSC staff are satisfied that the radiation protection program is effective. Program documents have been updated to reflect current standards, and no regulatory limits have been exceeded. Doses to workers are kept as low as reasonably achievable, and action levels are set at a small fraction of regulatory limits so that problems are identified early. The dose to the public is very low, orders of magnitude lower than naturally occurring radiation. CNSC staff are satisfied that McMaster University is performing satisfactorily with respect to radiation protection. Fire protection was identified as requiring improvement at the 2007 licensing hearing, mainly due to the high combustible loads within the facility. Since then, McMaster has made important efforts to reduce the combustible loads and improving housekeeping. This was verified during each inspection over the license period. McMaster has also submitted a fire hazard analysis and a fire safe shutdown analysis. CNSC staff verified and accepted both documents. McMaster submits third-party reviews of their fire protection program on an annual basis. CNSC staff have found these to demonstrate adequate provisions for fire protection. Overall, CNSC staff are satisfied that McMaster has made the required improvements and conclude that McMaster University is performing satisfactorily with respect to fire protection. To conclude on the areas of improvement, McMaster has made significant efforts to address the deficiencies identified in the areas of quality management, training, criticality safety, radiation protection, and fire protection. Compliance inspections performed by CNSC staff confirmed that McMaster completed the improvements identified for all of these areas. I will now move to CNSC staff's assessment of all 14 safety and control areas for McMaster, presented on this slide and the next one. These safety and control areas are standard for all licensees and represent important areas that contribute to the protection of health, safety, security, and the environment, including measures for non-proliferation. As you can see from this table, McMaster has achieved satisfactory ratings in management system, human performance, operating performance, safety analysis, physical design, fitness for service, and radiation protection. Improving trends are also noted on management system, human performance, safety analysis, and radiation protection. Other safety and control areas on this slide are shown to be stable. All safety and control areas on this slide are also satisfactory, and security is assessed as fully satisfactory given the significant upgrades and improvements made to the program over the license period. An improving trend was also observed in the areas of emergency management and fire protection. In the next few slides, we will look at some specific safety and control areas of particular importance at McMaster and that we have not yet discussed, namely safety analysis, physical design, fitness for service, environmental protection, and emergency management. Pool-type reactors like MNR are widely used around the world under different names and designs, and they are known for their simplicity, their reliability, and the safety of their design. The McMaster reactor operates at low power, a maximum of 5 megawatt thermal, making any severe accident extremely unlikely. The type of low-enriched uranium fuel used in MNR cannot burn or produce hydrogen as Fukushima did, should the core become uncovered. The reactor operates at near ambient temperature and pressure, eliminating the possibility of any significant release of energy in case of a system failure. As one of the safety features, MNR uses forced gravity cooling, which means that the cooling water flows downward through the core into a holding tank, and the water is then circulated back to the pool after running through a heat exchanger. This forced gravity flow ensures that, in the event of a power failure, the cooling water keeps flowing for a few minutes, which allows for most residual heat to be evacuated. Once the gravity flow stops, cooling turns to natural water convection without any intervention from operators or any complex systems, making it fail-safe. Although MNR has backup power in case of a power outage, it does not require any source of power or any other services to stay in a safe shutdown. In case of a prolonged power outage and without using the power generators, the large pool of water would increase in temperature by about 9 degrees and then cool down. The reactor core can also be moved to a different location in the pool, and the two sections of the pool can be isolated from each other with a gate in the event of a leak in the pool or in the cooling system. As another safety feature, the negative reactivity feedback inherent to MNR means that the reactivity, and hence the reactor power, tends to decrease as the core heats up. McMaster was converted to low-enriched uranium in 2007, and all HEU was safely repatriated to the US shortly after. Since then, no significant amount of HEU is kept at McMaster. The reinforced concrete containment building ensures that the reactor is isolated from the environment. During normal operations, a series of charcoal and HEPA filters ensure that the releases to the environment are kept to very low levels. With a power failure, or in the event of airborne contamination within the building, all ventilation shuts down and dampers close automatically, keeping the building in a boxed-in configuration and preventing any release of contamination. Following the conversion of the core from HEU to LEU in 2007, CNSC staff requested McMaster University to perform analytical work to confirm that the safety analysis report remains valid. McMaster communicated the results to CNSC staff over the license period, which confirmed the conservative assumptions used in the M&R safety analysis report. The report confirms that the design is robust. In 2012, and as part of several upgrades made to the facility, McMaster upgraded their source of backup power from the original generator to the university's set of 4 diesel generators of 1 megawatt each. This improves the reliability of the backup power. McMaster updated the safety analysis report to reflect this change in 2012, and the license was amended to reflect the updated document. Further to the Fukushima accident of 2011, McMaster University was requested, pursuant to subsection 12.2 of the General Nuclear Safety and Control Regulations, to review the lessons learned of the Fukushima accident and re-examine M&R's safety case, and in particular the underlying defense in depth, and to report on any plans to address significant gaps. McMaster submitted a defense in depth analysis which confirmed that McMaster makes strong provisions for the protection of workers, the public, and the environment, even under an event of worst conceivable proportions. The design of M&R is inherently safe, meaning that it does not require the intervention of active systems to keep it safe. Some improvement opportunities were identified, however, in the areas of emergency procedures and accident management, and McMaster has made the improvements, in particular with the use of fire water as an ultimate solution to cool the core in the extreme event that the pool would lose its water. Although M&R does not require any electrical power or any other services to keep it in a safe shutdown, McMaster installed an external connection to bring in external power, mostly for monitoring purposes, should the backup power become unavailable. Additional work is being completed to bring in a fire water outlet close to the core so that cooling could be maintained should the pool lose its integrity. These improvements result in an increased defense in depth of an already very robust design. I will now speak to McMaster's fitness for service. McMaster University maintains the M&R facility in accordance with a maintenance program and an aging management program that ensure the facility remains fit for service throughout its life cycle. In 2010, CNSC staff requested a report on the conditions of systems, structures, and components. McMaster submitted a technical report that described the condition, the aging mechanisms, and the inspection requirements for all systems important to safety. The condition of all systems was assessed as either good or very good. Non-destructive examination was conducted on the primary cooling system, and no significant degradation was identified. As part of M&R's aging management plan, McMaster performs several inspections and tests, including the annual containment building leak test. This test demonstrates that the building is maintaining its integrity. Also, the safety shutdown system is tested on a quarterly basis, and the high power trip test is performed twice a month. CNSC staff review the results of these tests on a continuous basis. As would be expected with an aging management program, McMaster has been proactive over the license period with upgrades to several equipment components. They have upgraded their electrical distribution system, their primary and secondary cooling system piping and pumps, and their fire protection equipment. McMaster also made important upgrades to their security monitoring system, upgraded their environmental monitoring system and area radiation monitors, and they've upgraded their backup power from their single generator to the university's 4 diesel generators. CNSC staff are satisfied with McMaster's performance with regards to safety analysis, design, and fitness for service. In the next few slides, I will discuss McMaster's performance in the area of environmental protection. McMaster has an environmental protection program consisting of an effluent and emission monitoring program. There are 5 environmental monitoring stations around the facility. Iodine-125 from isotope production, and argon-41 from the activation of naturally occurring argon in the air are the only nuclear substances released to the environment in any measurable quantities. Charcoal filters minimize the release of radioiodines, and HEPA filters ensure that any particulates that could be present in the ventilation system are controlled to very low levels. CNSC staff requested that derived release limits, or DRL, be calculated using the most recent CSA standard N288.1 methodology. McMaster established DRLs as well as action levels for iodine-125 and argon-41. There are no liquid releases from the facility. Any water is treated within the facility through ion exchange and recycled to the reactor pool. The following graph shows the annual releases of argon-41 over the license period. The trend has been mostly stable, with annual releases about 10 times below the action level. The action level is set at a level corresponding to a dose of 12 microsieverts per year. Similarly, this graph shows the annual releases of iodine-125 over the license period. The annual releases are less than 50 times below the action level. The action level is set at a level corresponding to a dose of 1 microsievert per year. And this graph shows the releases of radioactive particulates over the license period. The releases are extremely small, less than 1,000 times under the action level, which is set at a level that would cause a dose of 0.1 microsievert per year. To conclude on McMaster's environmental protection program, CNSC staff are satisfied that McMaster University implements environmental protection measures and practices that comply with CNSC requirements and applicable regulations. The dose to the public is very low, less than the dose that we get from natural background radiation. McMaster is performing satisfactorily with respect to environmental protection. I will now talk about McMaster's emergency management program. From an emergency management perspective, the risk associated with MNR is rated as low. It is a low-power reactor with a well-proven safe design, and it is fully contained within a containment building. McMaster is required to have an emergency preparedness program, and they are required to demonstrate that they can respond adequately should a nuclear emergency occur on site. McMaster has a well-developed emergency preparedness program. CNSC staff have assessed McMaster's emergency plan and found it to be satisfactory. McMaster has trained responders on site, as well as the equipment required in case of emergency. CNSC staff assessed a full-scale emergency exercise in 2010. The exercise revealed that McMaster is prepared to respond adequately to an emergency situation. CNSC staff noted some areas of improvement and issued action notices to McMaster for their response. McMaster took action to correct these findings, which included the purchase of new emergency response equipment. CNSC staff performed a compliance verification in early 2014, which revealed that all actions from the previous exercise were completed. CNSC staff also verified McMaster's notification system and met with Hamilton's fire chief. McMaster will hold another exercise in the fall of 2014, which CNSC staff will be assessing. In concluding on this SCA, CNSC staff are satisfied that McMaster has an emergency preparedness program that meets expectations, and they're assessed as satisfactory. I will now speak to McMaster's financial guarantee. As for other Class 1 facilities in Canada, McMaster University is required to have a financial guarantee for the decommissioning of their reactor. As with other university-based research reactors, McMaster has been building up a fund for decommissioning. Under McMaster's current guarantee, it is required to make contributions of $350,000 a year into a decommissioning fund. CNSC staff review the status of their fund every year. The current value of the fund is $8.5 million. The financial guarantee is based on the estimated cost of decommissioning of the reactor, which is documented in the Facility's Preliminary Decommissioning Plan, or PDP. This decommissioning cost was estimated at $12.5 million at the last revision of the PDP, and the PDP is revised every 5 years. CNSC staff are satisfied that McMaster has acknowledged full liability for the reactor and will continue to contribute to this fund as per the agreed schedule. CNSC staff conclude that the financial guarantee for McMaster remains acceptable. In other matters of interest, McMaster University has a comprehensive public information program through which they keep the public informed of any important matters such as releases to the environment and unusual events. The information is available in McMaster's annual reports, which are posted on the university's website. McMaster is found to be very engaged with the community, participating in public information sessions, fundraisers, and hosting visits. They usually receive over 2,000 visitors every year, including high school students and other interested groups. McMaster also engages the Hamilton Emergency Services in regular information and discussion sessions. The CNSC's regulatory document RD 99.3 was issued in 2012 and describes the requirements for a public information program for licensees, which includes a disclosure protocol. Although McMaster's public information program meets the expectations, proactive disclosure has only been done on an ad hoc basis, such as the radiation protection event reported to the Commission in 2011. The development of a formal disclosure protocol is in progress and is expected to be submitted within the first year of the new proposed license period. In concluding this presentation, CNSC staff are satisfied that McMaster has operated the facility safely and responsibly during this license period and will continue to do so in the new proposed license period. McMaster has made several improvements to the facility under their aging management program that continue to enhance safety. Their core programs are mature and meet the requirements under the license, the NSCA, and all applicable regulations. McMaster University continues to make adequate provisions for the protection of the environment, the health and safety, security, and international obligations. CNSC staff are committed to providing performance reports to the Commission on research reactors, including the slowpoke reactors starting in 2015. CNSC staff will include McMaster as part of these updates to the Commission. CNSC staff have developed a new license following the standard format, which includes 28 license conditions covering all 14 safety and control areas. This license is accompanied with a license condition handbook, or LCH, which documents the detailed verification of criteria for the conditions listed in the license. The LCH also provides guidance to the licensee for meeting the criteria and specifies the applicable reference documents such as regulatory documents and standards. As is normal practice, the handbook will be finalized after the Commission's decision to ensure consistency with the decision and its basis. Therefore, CNSC staff recommend that the Commission accept the recommendations outlined in the CNSC staff's CMD and approve the issuance of the operating license for a period of 10 years and endorse the delegation of authority to CNSC staff as outlined in the proposed license condition handbook. This concludes my presentation. We are now available to answer any questions that members of the Commission may have. Thank you.
Thank you.